Let's find H1 and H4. H1 is value at enthalpy point number 1. H1 equals to Hg at 50 bar. By referring steam table, it shows at 50 bar the value for Hg equals to 2794. So H1 is 2794 kilojoule per kg. Unit for enthalpy is kilojoule per kg. H4 is enthalpy at point 4. H4 equals to HF at 50 bar. By referring steam table also, we will find that HF for point number 4 at 50 bar is equal to 1155 kilojoule per kg. By referring the steam table also, you can find S1, entropy at point number 1. S1 equals to Sg at 50 bar. Sg at 50 bar is equals to 5.973. So S1 equals to 5.973 kilojoule per kg dot Kelvin. Also, we can find entropy at point number 4. S4 equals to SF at 50 bar. SF at 50 bar is 2.921 kilojoule per kg dot Kelvin. Let's find H2 enthalpy at point 2. Please pay more attention at this section because from my experience, many students have facing a problem to find H2. Let's look at our TS diagram. At point number 2, the steam is in wet condition. So, we must calculate the dryness fraction at point number 2 using this formula S2 minus SF over SFG. But remember, point number 2, the pressure is 0.035 bar. So we must find the value at 0.035 bar. Okay. We know that S1 equal to S2. So this equation will become to 5.973 minus SF. We find the value SF from steam table, 0.391 divided by SFG is 8.13. 8.130 is equal to 0.6899. Class, we know that dryness fraction also can be determined using enthalpy. X2 equals to H2 minus HF over HFG. So, this formula will become 0.6866 equals to H2 minus HF. HF is 112. Divide by HFG. HFG is 2438. 2438. So, you will find H2 equals to 1785.9308 kilojoule per kg. Next, let's find H3 enthalpy at point 3. First, look at the S diagram. At point 3, the steam is in wet condition. So, we must find the dryness fraction at point 3. X3 equals to S3 minus SF divided SFG. We know that S3 equals to S4. Therefore, this equation becomes S4 minus SF divided SFG. Remember, at point 3, the pressure is 0.035. So, let's do it. S4 equals to 2.921 minus SF. SF at 0.035 bar is 0.391. 0.391 divide SFG is 8.130. 8.130. So, X3 equals to 0.3112. We know that X3 equals to H3 minus HF over HFG. X3 is 0.3112 equals to H3 minus HF. HF refer to steam table. The value is 112. 112 over HFG is 2438. 2438. So, we solve the equation. Value for H3 becomes 870.7056 kilojoule per kg. Are you with me, class? Good. Now, I will show you how to calculate heat required. Heat required is a heat added at process 4 to process 1. This section is boiler section. To find or to calculate heat required is equals to Q boiler equals to H1 minus H4. So this is a value of H1, this is a value of H4. Just subtract these two values, you will find H required by the boiler. Okay. H1 equals to 2794 minus H4 is 1155. We will get 1639 kilojoule per kg. Next is how to calculate the work output. Work output is a work that produced by turbine. By refer the TS diagram, point 1 to point 2 is the turbine section. So W turbine becomes H1 minus H2. H1 is 2794 minus 1785.9308. So W turbine or work output is 1008.0692 kilojoule per kg. Let's calculate thermal efficiency. Given formula thermal efficiency, W net over Q in. W net is W turbine minus W pump, while Q in is Q boiler. Remember, W turbine and Q boiler we have calculated before. Now we must find W pump to get thermal efficiency. So how to calculate W pump? This is a pump section. So W pump equals to H4 minus H3. H4 is 1155, H3 870.7056, we'll get 284.2944 kilojoule per kg. So thermal efficiency equals to W turbine 1008.0692 minus W pump minus 284.2944 over Q boiler 1639. So we will get 0.4416 or 44.16%. Let's find work ratio for this system. This is the formula of work ratio. Work ratio equals to W net over W gross. W net is W turbine minus W pump. W gross is W turbine. We have calculated W pump and W turbine before. So, we can calculate the work ratio. Work ratio for this system equals to W turbine minus W pump divided by W turbine. So W turbine is 0692 minus 284.2944 over W turbine 1008.0692. Okay, so you will get 0.718. Last question. How to determine the specific steam consumption? As you know, specific steam consumption is equals to 3600 divided by W net, which is W net equals to turbine minus pump. So SSC equals to 3600 divided by W turbine. So W turbine is 1008.0692. W pump minus 284.2944. So SSC equals to 4.9739 kilogram per kilowatt hour. Okay class, let's refresh what we have learned today. We have learned Carnot cycle, which involve isentropic expansion and compression process. We also learned how to determine work ratio, specific steam consumption, and efficiency of Carnot cycle. Before we end our class, I hope you can do this tutorial at home. Remember guys, with money you can buy a book, but not knowledge. That's all. Until we meet again. Bye.
I tried so hard and got so far.